All right, these are the 5.6 notes for Algebra 2 covering composition of functions. So our first example gives us two functions, f of x equals 2x plus 3 and g of x equals 5x minus 4. And that's supposed to be part A. All right, if you notice, this g of x function is actually inside the parentheses of the f. So we are going to plug in g of x into f of x. So you can circle this g of x, and we're going to put it inside, and it's going to get substituted in for that little x right there. So it would look like 2 parentheses. This x comes out, and 5x minus 4 takes its place. And then make sure you finish the rest of the f equation, f function. After you set it up, you would perform your basic operations, distribute, and combine like terms. There we go. All right. So for part B, this is now asking us to go the other direction. So we want to plug in f of x into g of x. Notice how this f of x is inside of the parentheses of g. So we're going to take f of x and plug it inside for g. We're going to replace that x with the 2x plus 3. So I'll write it as 5. Then we plug in. And don't forget to continue writing the rest of that function. From there, we distribute. Bring down the 4. And combine like terms, the 15 and the negative 4 would get me positive 11. All right, for the next problem, example 2, this one looks a little bit different, but it's asking us to do the same thing. Express your answer as a polynomial in standard form. Standard form means you're going to write your largest exponent first. All right, so f of x is x plus 8, g of x, 5x plus 11. Then find g of f of x. F of x is inside, so f of x is going to go into g. Plug f of x into the g of x function. So I circle the f of x, and I'm going to plug it in right there for the g of x. When I do that, this x is going to go away, and the x plus 8 will take its place. Negative 5. Plug in, finish the function. Then we would distribute. And combine the like terms of 40, negative, and 11, which would get us negative 29. Example number 3. We're going to plug g of x into f. G into f. Now what I might do is I might write this f of x function as negative 1x plus 4. I like to have a number in front of there. So see if you can plug this in right there for that x. So the x comes out, and the 2x squared minus 3x minus 6 takes its place. Most mistakes happen as students are plugging it in the first time, making sure they're plugging it in the correct way. So see if you can do that one. Let's check to see if you plugged it in right. You should have negative 1, 2x squared minus 3x minus 6, plug it in, and then don't forget the rest of that other function plus 4. Then we'll distribute. Negative 2x squared plus 3x plus 6, and I'll bring down the plus 4 at the end. Then I'll combine like terms. The only like terms I have are at the very end here. The two regular numbers, the 6 and the 4, add those together to make 10. Example 4. All right, this one they set up again a little bit differently, more like that very first example we did. The first part, part A, is asking us to plug G into F. So you can almost think about it as G gets plugged into F. G gets plugged into F. So we can put the 3x to the 5th where this x used to be. And then don't forget to write the rest of the function. That little square right there is all that's left. And we can evaluate that. 3 squared, which is 9. And then I multiply the exponents to get x to the 10. So I do 3 squared, and then I do 5 times the 2. 3 squared, and then 5 times the 2. All right, part B asks us to go the other direction. So now we're going to plug F into G. So plug F into G. So it's going to take the place of that little x. This little x is going to come out. So I write 3, take the x out, and substitute in the x squared. And then don't forget to write the rest of the function, exponent of 5. Now, because this 3 is on the outside of the parentheses, it drops straight down. And then x squared to the 5th power would be x squared 2 times 5, which would again give me 10. So notice I got very similar answers for part A and part B. Just my number is different, the 9 versus the 3. On example 5, just asking for one thing here. They gave us f of x, they gave us g of x, and they ask us to find f of g of x, which means g is going to go inside f. G gets plugged into the f right there. Take a moment and see if you can plug it in correctly. You should have written 8, parentheses, x to the 1/3, close the parentheses, and then the 1/2 goes on the outside. Because the 8 is on the outside, it drops straight down into the answer. And then this is a power to a power. So this is the rule where we multiply. So we multiply 1/3 times 1/2. And you just multiply the numerators together. 1 times 1 is 1. And the denominators, 3 times 2 is 6. And we get x to the 1/6. Our last example, example number 6. They give us 2 new functions, and they're going to ask us to find g of f of x. See if you can set up the problem correctly. Go ahead and give it a try. F should get plugged in for G. F should get plugged in for G so that x comes out and 9x to the 1/4 will take its place. All right, you should have written 16, parentheses, 9x to the 1/4, close the parentheses, and then taken it to the 1/2 power. All right, I'm going to drop the 16 straight down. Because the 9 is inside the parenthesis, it is being affected by that 1/2. So what I have is 9 to the 1/2, as well as x to the 1/4 being multiplied by 1/2. Now 9 to the 1/2, we're going to write as a root, putting a 1 at the top and the 2 at the bottom. The square root of 9 is 3. 3 to the first power is 3. Over here on our x's, I'm going to multiply the numerators to get 1, denominators to get 8. So what I have is the 16, the 3, and the x to the 8th. I'm going to multiply the 16 times 3. 16 times 3 is 48. And then I'll just bring down the x to the 1/8 power. And there's my final answer.